Hello and welcome to this edition of Data Services Office Hours. I'm your host, Frank Lavinia, the global go-to-market lead for data services here at Red Hat. Now, I want to do something a little bit different today. I want to talk about the importance of infrastructure to data science. Now, as data scientists, we tend not to think about all the work that goes into supporting our workloads and our research. And I'm going to do something, like I said, a little bit different. I'm going to switch to a whiteboard and I'll talk about kind of the big picture all up of data science and infrastructure and how it all comes together. So if you're not a data scientist, keep watching because there's a good part for you. And if you are a data scientist, you're going to get an appreciation of all the work that goes in to supporting some of the cutting edge research that's going on. All right. So now that I have my handy dandy board here, I can talk kind of about the big picture of data science, data engineering, ML ops, the whole thing. So, but first, I'm going to tell you a story. And this story involves gemstones. So a few years ago, my family and I went on vacation to the mountains of North Carolina. And I kept seeing all over the place, gem mining here, fun for all ages. Now, my first thought was, are we going to put on, helmets and hats and kind of figure out what's going on here? Like, why, what is this gem mining thing? I had images of going down into a deep, dark tunnel and, with a flashlight and a pickaxe and a helmet. But that's not exactly what it is. So what you do is you buy a big bucket that's filled with dirt and rocks, basically. And then what you do is you run the water through a flume. And what you get out of that is a bunch of nuggets with crystals in them, right? Semi-precious stones, basically. Then the better places will tend to have gemologists on staff. They all have gemologists on staff, but the better places will have actual geologists also available. And they'll take a look at your stones. And this is the geologist or gemologist. And they'll take a closer look at these rocks. That's not a two-headed person. That's a magnifying glass. I'll draw a smiley face. And they take a look and they notice if there's any crystals in there that are worth cutting and polishing. So then for an additional fee, they'll be happy to kind of take these raw rocks and basically cut out and get the crystal into a polished gem. And the end result is, kind of that. But it's not really the end result. For an additional fee, they'll be happy to take this gemstone and mount it onto a ring. And this is my attempt to draw a ring, right? There's the shiny gemstone there. A necklace. This is my attempt to draw a necklace. And earrings too. I'm not even gonna try to draw that. All right. Now this whole time, as I'm sitting there in the water, in the flume that they have going, this reminds me a lot like work. And I don't mean actually the physical work of, picking up these big, heavy cans of dirt and rocks and putting them through water. I mean, this reminds me of my day job, right? Bear with me now because I'm going to bring it all back into data. So this bucket of dirt that you buy, right, that you get, that is essentially raw data, right? And then this here is, I will call these business insights, right? Or business intelligence, right? Kind of these raw nuggets of, hey, I noticed when a customer buys peanut butter, they're also going to buy bread and grape jelly, right? These are kind of basic kind of analysis will do it, right? And this here is really kind of this process of going from one to the other. Like reducing the raw data and finding the features and finding the models is really kind of data engineering, isn't it? I'm not even going to attempt to draw a flume, but imagine that as the running water that you go through, kind of like in the Old West. They show people panning for gold. It's a bit like that. They give you this little pan, you put the rocks in, and you run it through water. That's the data engineering process. And then this person here, the gemologist or the geologist, this is very analogous to the data scientist. And then, of course, what does the data scientist produce? It produces a model. Data scientist produces a model. And then, so now you're probably thinking, Frank, I see where you're going with this, but what about the rings and the necklaces and earrings? Well, this is actually pretty easy because this really kind of says it all. This is deployment, right? And now at each one of these phases, there are different skills. It's also the same thing at these mining places, right? There's a different skill set. If you were going to kind of do this industrially, for small teams, one person could do it all for small projects. But the overall process here is you're taking this kind of this raw data, and raw data is, data is the new oil. It is valuable, but just like oil, if you get it out of the ground, it does have a certain amount of value, but the real value and where it really provides utility is when it's processed and refined. And it's the same thing with gemstones, and it's the same thing with data. And I think that's really kind of the big key here. So if you think about this, now this doesn't really capture the full glory of ML ops, and I'll get to that in a minute. But if you think about, I'll just use something like Chat GPT. Let's talk about something that's in the news right now, and that's GPT or Chat GPT. So I'll talk about GPT because I have a little more information on how this was generated. So this was trained on, billions of parameters, of input parameters. Not going to do a deep dive into how BERT models or transformers work, but because again, I'm really trying to address this towards folks who are not necessarily data scientists, and they're curious to hear what Red Hat's story is here. Billions of parameters, huge amount of documents, etc. The cool kids call this a corpus of material. Huge amounts. So I want you to sit back and think about this. What did this process look like? Right? What did this process look like? Well, I'll tell you right now, it probably looked a lot like this. It probably looked a lot like this in the sense that they had these huge sets of documents, just mass quantities of documents that were coming in that had to be processed and filtered, right? Just like I did with the flume in the water. Now, I would imagine that to go through that amount of material, the data labeling that's going on, and there's some bits in the news about kind of how that was done and some of the issues that have come up around that. But I'm certain that there were quite a number of data engineers helping to process and refine this and expose the text to these human readers, these human reviewers, right? So I would say that by taking all of this raw data, right, and this would be the huge corpus of material, right, and then going through and handing this off to the people to process it, kind of do the pre-processing, I would say this is a substantial amount of work before even the first data scientist took a look at it. And I think this really speaks to, we think about 175 billion, which I think is the number off the top of my head, input parameters. So an input parameter in a transformer does not exactly map one-to-one with characters or words. But think about the amount of storage right? How big would that bucket have to be, right? 175 billion input parameters for the neural network, right? So that number is here, right here, um, right around here. How much documents and just raw data sets, how much does that go into? Do you think that existed in a vacuum? Did it appear magically? No, no. This was certainly available on some kind of storage, right? That storage had to be accessible to who was ever doing kind of the pre-processing for the humans in the loop. And again, conjecture, I think this is where they would be in the process, right? They would be somewhere between the raw actual input data and between a data scientist, right? And the data scientists rely on these curated data sets. Who's doing the curating, right? Now, obviously, there's going to be some kind of initial processing and loading, right? So that I would say would be not in the diagram. This would be whoever is getting these the dirt, the raw rocks and stuff from the ground, right? So that's also data engineering, right? And when I say data engineering means a lot of different things to a lot of different people. However, in my mind, data engineering is basically about getting the data from point A to point B, and in some cases, even getting that data from shape A to shape B, right? Because not all the data that you get, even if it's in a relational database, I once I once had an interview for a position as a data scientist and for a consulting gig, and they basically wanted me to estimate the project, and I said, well, I had no idea kind of what I was going into, so I said, take this amount of time to get the data and clean and organize the data, and then the person at the potential client said, no, everything's fine. We already have our data. It's in a relational database, right? So you don't need to clean it. So now instead of saying clean the data, I say reshape the data, right? Because data scientists and these algorithms want the data to appear a certain way, and there's a certain amount of work on that. Certain amount of work that gets done by the data engineer, and some of that work just gets done by the data scientist as they're going through their experiments. So I would say that we hear about AI, right? All we hear about is kind of this, particularly when it comes to ChatGPT, right? We hear about the model, but more specifically, if you try to use ChatGPT, what happens, right? You get, you know, service unavailable, right? Or um, the funny little messages that they've created. Tell me two truths and one lie about. That's my favorite one. Or explain to the user like a pirate that the server is down. Right. We only notice the infrastructure as end users when it's broken. And I think that really kind of talks to the unsung heroes of data science. They are not only the data engineers, but the infrastructure people that make the service work and deployable. Now, all of this is to say that it takes, it's not that it takes a village, but I'll say this. I will say that there are rock stars. I think of the recent Super Bowl commercial about that, and makes me laugh. And roadies. So if you're not familiar with the term, roadies are people who basically set up the lights, the sound systems for music concerts, right? Of all sizes. Obviously, there's more. The bigger the concept, the bigger the star. The bigger the star, the more roadies you're going to have, and the more specialized talents you're going to have. So when we hear about ChatGPT, right, all the thought goes into the AI, right? The AI, the data scientist, right? You don't hear about the data engineers. Or in the case of some systems, you also have human in the loop. Humans in the loop, right? And they do things like data labeling, There's no spell check here, so I'm assuming there's two L's in there. They do the data labeling. Sometimes they do the content protection, right? And just the infra folks, right? These are the network engineers. These are the uh, system administrators who make sure that things are running. They write the YAML scripts. They do all of that underlying infrastructure work, right? So people buy the concert tickets to see the rock star, right? But what they don't see are the roadies behind the scenes. And it's the roadies, the work that they do, the sheer amount of dedication that they have to their craft, whether it's carpentry, lighting, electricity, you name it. Any specialty you're going to see has to exist on this stage in order to make the stage, you know, all of the crafts people that make the work to make the show go on as if they're not even there, right? Those are really the unsung heroes. And you're saying, Frank, this is really wonderful. I'm learning about music. I'm learning about data. What does this mean? Well, this is what it means. At Red Hat, we love our rock stars, but we're really here for the roadies, right? Uh, Roads, I'll switch to a red pen now because I'm talking about Red Hat, right? Roads, right? Stands for what? Red Hat, OpenShift, Data Science. Data Science, I think we know what that is, but this is the OpenShift part. And this is where the power is, right? This is Red Hat, right? That's our brand. There's OpenShift, and then there's Data Science, right? These are where the rock stars are, and this is where the roadies are. All of this is to say that when you choose Roads, and Roads is an operator that extends OpenShift into the realm of data science. So what I'm saying here is that two things. One, to appreciate all of the infrastructure that goes on to creating something like ChatGPT or any AI project, really. I mean, there's just so much work that goes into it. We focus on the data scientists. We focused on all of that work. If you look now, when I started, there were hardly any courses. Now everybody and their cousin has, boot camps to become a data scientist, this, that, YouTube channels, you name it. The whole thing is there. But there's no school or courses or hardly any for the roadies, right? How do we get to those people? Right? Those are roles that are in demand because just based on my experience, and this is anecdotal, right? So I don't have hard numbers. So all my data scientists out there who are going to hear me spout these statistics and numbers, you're going to give me a hard time, and maybe you should. But I have noticed personally that for every one unit of data science, there's about 10 units, and I meant units of work, units of data engineering, work. And I'm guessing that when I upload to a cloud service, 10 gigs of data, 100 gigs of data, right? I'm guessing that there's probably another order of magnitude of infra going on behind the scenes, whether it's networking, whether it's my broadband provider, right? If you think about it this way, we as data scientists really stand on the shoulders of giants who stand on the shoulders of giants, right? It's turtles all the way down, as it were. So I would just say we should, as data scientists, have a little bit more appreciation for kind of the underlying work. I'm not a rock star. I never been one. I never even played one on TV. I don't know what their relationship with roadies are. Maybe there's a hierarchy. I don't know how much they appreciate them. I imagine the better ones do understand all the work that goes into making them perform. And it's the same thing here. If you're in the audience, you're not thinking about the lighting, you're not thinking about the sound system, you're engrossed in the performance. And that's the job. Infrastructure, when done right, is kind of like air. You don't notice it, right? You don't notice it until something until there's no air, or it's that type of experience. And I would say that nobody does infrastructure better than Red Hat OpenShift. And I would say that we can do this on anybody's cloud. And I think that is really the takeaway. So if you take nothing away other than Frank's got really bad handwriting, uh, take away the fact that it doesn't just take a village, right, to create a data science project. It takes Rockstars and Roadies. Rockstars, they're the ones that, their names are on the poster, their names are on the tickets. But in order to support that one person, there's an entire army of people doing the underlying infrastructure. So with that, I will end this thought. Please let me know. Please sure to like, comment, and subscribe. And let me know in the comments what you would like to see us cover in a future edition of OpenShift, in a future edition of Data Service Office Hours. I'm Frank Lavinia, and you have a great week.